All right, so here we're in section 9.6 on differentials. We're looking at increments, differentials, and approximating things using differentials. Let's say, okay, so increments and differentials. Well, increments are useful and they provide an alternative notation for defining the derivatives. Differentials are often easier to compute than increments and can be used for approximate increments. Now, the symbol delta x does not represent the product of delta and x, but it's actually the symbol for a single quantity. Now, the change in x, so delta means change, and so that's why it's called the change in x. Likewise, the symbol delta y represents a single quantity. Again, this time though, it's a change in y. So looking at increments here. So if we have y equals f of x, then delta x, which is the change in x, is just taking x2 minus x1. And so then we can look and say, okay, well, the x2 is equal to x1 plus delta x. If we go and add it to the other side, and then delta y is going to be the change in y. So that's going to be y2 minus y1. And what is y2? Well, y2 is going to be depending on what f of x is. So that's going to be f of x2. y1 is going to be depending on what y1 or x1 is. And so it's going to be f of x1. So we can just substitute the function notation, from here into here. And then what we can do is we can say, okay, well, this is going to be f of x1 plus delta x, because remember, this is what this is over here. So that's x2, and then minus f of x1. So delta y represents the change in y corresponding to a change delta x and x, and delta x can be either positive or negative. And so kind of looking at this graph, so our blue line is our f of x. And then we have 0.1 and 0.2. And so the change in x is going from this x to this x. And so we take the second one minus the first one. And so we're going from here to here. And so that will give us delta x. And our y is going from basically here up to here. And so the delta y is that change. So we take the y value, or f of x2, minus the f of x1, and that's going to give us the delta y. And again, another way to look at that x2 is through this here piece right here. We can say, well, that's going to be f of x1 plus delta x. And so we can have that. Now note delta y depends on the function f, so the input x1 and the increment delta x are all kind of required to get all these pieces here. All right, so let's look at this. And so this one says, given the function y equals f of x and x squared plus 1. So what we need to do is we need to find delta x, delta y divided by delta x, for x1 is 2 and x2 is 3. All right, so first things first, let's go ahead and do A. And so delta x is going to be what? Well, it's going to be x2, 3 minus 2. So that's going to be 3 minus 2, which is going to be 1. Now delta y, that's going to be what? Well, now we have to plug in our x's. So x2 is 3. So if we plug in 3 here, 3 squared is 9 plus 1 is 10. So the first y is going to be 10. Now if we plug in 2 here, that's going to be 2 squared is 4 plus 1 is 5. So that's going to be 5. And 10 minus 5 is 5. So now we have delta x is 1, delta y is 5. Now they also want delta y over delta x. So delta y over delta x is equal to 5 over 1. And that's just going to be 5. All right, so now it says what we need to do is find f of x1 plus delta x minus f of x all over delta x. All right, so for B, they tell us x1 and they tell us delta x. And so we just have to plug those in. So let's just plug them in and then we'll figure out what we have. So x1 is 1 plus delta x is 2 minus f of x1, which is 1, all over delta x, which is 2. So that's going to be f of 3 minus f of 1 over 2. Well, f of 3, well, that's going to be the same as this one. So that's going to be a 10 minus f of 1. Well, if we plug in 1 here, that's going to be 1 squared, or 1 plus 1 is 2. And then we have over 2. So 10 minus 2 is 8 over 2. And that's going to be equal to 4. Okay? So that's how we can use our deltas and plug everything in and get our values out what they're asking for. So let's stop there and we'll come back for more.